Hey folks, welcome to my channel Number Pin. So there we have the problem on the screen. Integrate the following with respect to x. We have x square times cos x, right? So what we have been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down our y. So that's my y, integral of x square cos x dx. Now I know that I'm not in a position to solve this by the method of substitution, but then my y is in a very complex format whose antiderivative I do not know from first principles or any of the identities that you have learned so far. However, I see that y has a format integral of u dv, right? Therefore we can apply integration by parts. So what does my integration by parts tell? Integral of u dv equals uv minus integral of v du, right? So the key to solving this problem is choosing the right u and v, right? Now my u has two possible options. It has an x square or it can also take a cos x, right? And whenever you see a problem of the type x to the power n as one of the parts to a problem which you think you can solve using integration by parts, then I would suggest go ahead with u equals x to the power n. In this particular case it is u equals x square, right? So when my u equals x square, what is my dv? It is nothing but cos x dx, right? Now I know my u, I know my dv. To complete my integration by parts, I need my du and v, right? So my du is 2x dx, and when my dv is cos x dx, my v is quite simple. It is a sin x, right? And we observe our constants when we finally arrive at the solution for this particular problem. So I have my u, I have my v, I have my du, I have my dv. Okay. So now I go back to my integral by parts. So my LHS is nothing but integral of x square into cos x dx. And my RHS, which is nothing but has two parts. First part is uv, which is x square times sin x, right? And then I have a minus of integral of v du, right? And what is my du? It is 2x dx. And what is my v? It is sin x. So my v du is nothing but integral of 2x sin x dx. I can pull out my 2, and therefore I'm left with 2 times integral of x sin x dx, right? So now my RHS has got two parts. One is an x square sin x, which I do not have to worry about. And the second one is an integral of x sin x dx. Again, I do not have this in a very simple format, right? Therefore, I will have to apply integral by parts once again because this function as well is of the form integral of u dv, right? So now you understand why did I insist on choosing u equals x square. If you've not taken u equals x square, and if you had taken the other function, okay, as u, which in this particular case is cos x, right? dv would have been x squared dx, right? And when your dv is x squared dx, what is your v? It is x cubed by 3, right? And what happens is in this particular case, the RHS becomes even more complex, right? Because integral of v du, right, becomes x cubed by 3 times minus sin x dx, right? So that is what happens when you choose your u equals cos x dx. So whenever you have u equals x to the power n, you realize that this is a problem where you will have to apply integral by parts successively, right? In this case you have x square, and therefore you will end up applying integral by parts twice. And when you choose u to be the other function, you will instead go and increase the power of x in your subsequent integral by parts. So you're not actually making the problem simpler, you're making it even more complex in a way. Now let's come to the second integral, which is integral of x sine x dx. Right? I do not have to worry too much about the substitution because here again, go ahead with u equals x and dv equals sine x dx, right? So let me move this to one line, and I'm going to highlight this with an yellow color so that you folks are able to differentiate this when you read through the problem. And now I'm going to highlight my x sine x dx as green, right? So now for the integral of x sine x dx, again we have a substitution where my u equals x, my dv equals sine x dx, means my du equals dx, and my v equals minus cos x, right? So this is what we have, and let me highlight my entire line in green. So now I'm going to treat this integral separately before I come back to this expression. So let's write down what is our integral of x sine x dx. Again, I apply integral by parts. Okay. So my uv, which we know from what we have highlighted in green, is minus x times cos x, right? And minus of integral of v du. Now let's write down that my integral of v du is nothing but my v is minus cos x. So I will have this becoming a plus, right? And then I have my du dx, right? So I know the answer for integral of cos x dx, right? This is something that I'm expected to know from first principles, and therefore I have minus x cos x plus sine x, right? So this is the answer for integral of x sine x dx, right? Again, I'm not worrying much about the constants right now. I'm going to put my constants when I have the final answer. Right now I go back and I know that I have more or less arrived at what we want. It's just putting in place what we have arrived at for integral of x sine x dx, right? I have integral of x square cos x dx equal to, my first part doesn't change, it is x square sine x, right? And then I have minus of 2 times. Remember that this is where we can go wrong. Sometimes we tend to miss the number out here. And then we have minus 2 times minus x cos x plus sine x, right? And here I bring in my constant, which is plus c. Therefore, my answer to this particular problem, which is integral of x square cos x dx, is nothing but x square sine x plus 2x cos x, right? Minus 2 sine x plus c, right? There we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.